Close enough? Okay, at least you know I'm talking to you.
Do I do this? Thank you for inviting me to this exciting venue. It's a great honor. So I study how the climate system and the land surface, particularly how plants interact with each other. And I also study how over geological timescale, ecosystem and the climate system co-evolve. So how plants influence the climate system? So we have trees slow down the wind, and if you take a look at this figure, you see that forest is darker than the bare ground. So it influences the amount of energy that Earth absorbs. And also plants transpire. Transpiration means that evaporation over leaves. So plants take up water, and when they photosynthesize, they open stoma, and CO2 diffuses in, and plants assimilate carbon. While they're doing that, because this pore is open, water diffuses out. That's called transpiration. And just like us sweating, by doing that, the temperature near the surface decreases. So plants really influence the energy and water cycle of the Earth. And today, I'm going to talk about how plants influence precipitation and also cloud types over Amazonia. To the next slide. Thank you. So this is a hypothetical case that if we have plants, but suppose that we don't actually photosynthesize or transpire. So you can think of trees are there, but they're like plastic trees, so they don't really work. I'm a climate modeler, so I can do the kind of experiments that we cannot do for the real world. So for this case, I pretended that the Earth is covered by plants, but they don't photosynthesize or transpire. So, and how that's going to influence precipitation intensity. So what this figure shows is that this part is low precipitation to very light precipitation, and this is heavy precipitation. So, and you can think of it as number of days per year. So, for example, if we remove transpiration, we are going to have probably 10 more days of no precipitation, and we are going to have a bit more intense precipitation. The reason why the difference is high here and low here is that we have relatively less number of days with very intense precipitation. So by having plants, so in this case it's removing plants, right? So if we remove plants, we are going to have many more dry days and many more very, very, with many more days with extreme precipitation. That's because, if we don't have plants, I mentioned that, when plants photosynthesize, they decrease the surface temperature. So if we remove plants, temperature is going to go up, and if temperature is higher, we need more moisture to be able to initiate precipitation. So as a result, extreme precipitation, both low and high ends, increase. So this is for the case with the Amazon. So here I'm going from 30 west. This is over Atlantic Ocean, and this is Andes. So I'm looking at the longitude here, and this is so from here to there. So if I don't have any plants, the time that matters most is October. That's the onset of the wet season. And what you see is that most of precipitation occurs near the Andes. So mean wind here is easterly, meaning that wind is blowing from the east, from the ocean. And then it hits the Andes, and major precipitation occurs here. But because we have Amazon basin with large evapotranspiration, now we have more precipitation here in Brazil, over Amazonia. So precipitation in Amazonia, and particularly the frequency of precipitation and the length of the rainy season, depends on the existence of the forest. So I looked at the timing of the wet season. So as I mentioned, if we have plants, wet season comes much earlier. If we don't have plants, wet season would come much later. So this is actually a case with high transpiration and low transpiration. So historically, in terms of geological history, plants have evolved toward flowering plants, and flowering plants appeared about 130 million years ago and became dominant maybe around 65 million years ago. We are not sure whether it's before or after dinosaurs disappeared, but around that time. So that's when tropical forests became dominantly flowering plants. So this case is if the Amazon is covered by plants that don't transpire much, unlike the flowering plants like ferns or other types of plants. When the rainy season would start. So if present day, on average, rainy season starts about late October, October 26th. So that's just the average. But if we don't have plants transpiring, so during the transpiration, basically forests provide large amount of water to the atmosphere, so that that water can precipitate out. And in that case, wet season starts in January 10th. So it's more than 2 months of the rainy season difference. And take a look at the duration. It's about like 80 days difference. So plants are really important in terms of determining precipitation amount, frequency, and also the duration of the rainy season. And this is the observed precipitation in the Amazon. So this is the difference between this period and the earlier period. So later period minus earlier period. And what you see is that over the northern part, precipitation is increasing, and over the southern part, precipitation is decreasing. And so this is my study, and other people have shown that the length of the wet season, and particularly the onset of the rainy season, might have delayed during the past years. And over the same time, what we see is the changes in the greenness of the land surface. So this is the data from the satellite. So we use the fact that plants observe a lot of visible light, because chlorophyll observes blue and red light, but bare ground, but they don't. Let me pick up. So plants absorb a lot of visible light, but not near infrared. But bare ground, there's not much difference. So by looking at how visible light and near infrared light is absorbed by the land surface, we could see how much biomass we have. So that's this satellite observation, and you can think of it as how green the land surface. So I'm looking at that difference for the same time. So later period, from mid-90s to early 2000s, minus 80s and early 90s. And what you see is I am only looking at the September, October, November case, because during the wet season, because it's very wet, we don't really see much difference. And the time that the land surface is driest is the later dry season or early wet season. So what you see is that this part of the region becomes greener, and this part of the world becomes browner, which is very similar to the precipitation pattern. So they're self-consistent. And I did some modeling study and trying to figure out why we have this type of precipitation change. We call this attribution study. So there are probably different factors that influence precipitation over this region. And I have two possible candidates for the possible change. One is remote sea surface temperature forcing. So what we observe is that during the past 30 years, there's more warming in regions over land, because land doesn't have high heat capacity. And more warming over land, more warming in the polar region. In the tropics, we have more warming in the regions around Indonesia, and we tend to have less warming in Eastern Pacific. So this type of sea surface temperature pattern has influenced the precipitation. And most of the precipitation change in the northern part is due to the change in the remote forcing by sea surface temperature. And the dots here is where the difference is statistically significant. And then this one is vegetation only. The changes in land use, how that's going to influence. And particularly the southeastern part, precipitation changes seem to be coming from the vegetation change. And when we combine them together, it's smaller than the observation, but it captures the major pattern. So I'll just let you know that precipitation is very difficult to simulate in a model. I consider this like a success. So plants influence precipitation, and how about like cloud types? So I'm looking at the satellite data that shows the vertical distribution of cloud water. So you can think of it as radar on the satellite. So this is cloud types over savanna. This is August, September, October, November, etc. The blue part here is the wet season. This is height. So this means that in August we see mostly low clouds at about 4 kilometers. And in December, we start seeing clouds at about 10 kilometers. So clouds here is mostly made of cloud liquid water. And cloud